Good afternoon, everyone, and welcome to our webinar on early warning system for fraud detection. In this webinar, we are going to talk about how we can augment traditional fraud modeling and fraud detection by using an early warning system. Yeah. Okay, so let's get started. So let's talk about the fraud detection window. You could detect fraud at the time of loan origination. So this will help you prevent loss, um, and it will provide you learning for better defense. But also you could, when the loan is early, you could detect fraud at that point too. And then you have some possibility for recovery, and it provides learning for better defense. And then if you detect fraud later, late in the period, that point you probably don't have a lot of hope of recovery or prevention, because the loan has already been given and probably the fraud has already occurred, but it still provides learning for better defense. And the focus of this discussion today is loan origination, and how to prevent fraud and detect fraud at this stage. Okay. And that is what we call the early warning system. Okay. So components of early warning system, approaches to fraud detection at the time of loan origination. Basically, there are three components, all of which should be used in conjunction, if possible. Okay. Inconsistency detection, where you look for logical inconsistencies, and we'll talk more about that. And then there is traditional supervised models, and then we will also talk about unsupervised models for fraud detection. So let's get started with each of these components. Inconsistency detection. So automated scripts scan applicants for red flags. So that's kind of a high level approach here. What are these red flags? Inconsistencies within the application, valuation inflation based on recent similar loans, uh, discrepancies in PG information when matched to demographic database, discrepancies in borrower or leasing firm information when matched to firmographic database, recent spike in credit activity baseline to similar size borrowers. So all of these, one should set up scripts to check for these, and these should together become kind of uh, logical, just red flag system which just looks at the data which the applicant has submitted, and looking at it, tries to figure out if something seems off. Another important thing to remember is these rules are static and should be periodically reviewed and revised to keep up with changing fraud patterns. Next, we will talk about supervised traditional models. So supervised traditional models, there is the algorithm, there is the data, and then there is the infrastructure. Infrastructure is also very important because you need to know what to implement and how to implement. Data on fraudulent transactions are collected. Along with it, account level credit, firmographic, and transaction data are collected. Then the model is built using data science techniques. Okay. And these techniques have to be suitable for rare event modeling, can be machine learning. And then the model is scored and potential fraud is flagged. So that's kind of the way it works. Some of the key things to think over here are, is the uh, what is the frequency with which you want to do it? Does this need to be overnight, or does it need to be real time? Or these are things, depends on how you approve your loans. If you are approving your loans on real time, then the fraud system should also be running real time. Mm. In terms of the data, you have to make sure all the components you're using are available in real time when you are scoring it, and your algorithms you use should be supported by the infrastructure. Now, one challenge about this is that way this works is it looks at fraud, and then it looks at a whole bunch of predictors and tries to build a model. So there might not be enough data to enough fraud data to build a good model. That is always an issue. Fraud patterns might change, making model ineffective, and model has to be regularly recalibrated. That's one big thing in fraud modeling. You have to always uh, keep up. You just can't have a model built and just let it lie there and just score it. The model has to be dynamic. It has to constantly learn from existing fraud patterns, and and uh, um, uh, build out for that. And this is where unsupervised model becomes kind of important. Basic premise. uh, we all say chameleon can change color, but and camouflage itself and look different. But while it can change color, it still differs on shape, size, and texture. So that is the key thing. Fraudsters might mm, put some things in front of you, and based on that, they might look um, good. But what if you expand what you are looking at and look at greater dimensions? Do they still look the same, or do they start looking different? And this difference is what can set off our fraud alert. If you look across multiple dimensions, they might not have masked everything. And that is where, if you dig deeper, look at multiple dimensions, you might detect the fraud. So that is the whole point of this unsupervised model. So a key thing over here is, we must remember, we are not looking at actual flagged fraud, actual incidents of fraud to do this. Rather, we are looking across a large number of expanded set of characteristics, and then we are looking at over that expanded set of characteristics, we are looking at machine learning algorithms, and then we are flagging accounts to be investigated or monitored for fraud, because we see anomalies when we expand that dimension. And um, uh, um, so this does not require fraud data, though if available, that can definitely be leveraged in the system. Uh, the This algorithm does not require fraud data to be functional. That's very important, because fraud data might be hard to come by. And since it tracks different characteristics to identify the non-conforming accounts, it can detect changes in fraud patterns as well. So that's also very important. So it's not static. It is looking, and it's always looking across these several dimensions and um, finding anomalies. So you know it is not going to, and not looking at actually how the fraud happened, but rather looking at the applicant um, across a lot of dimensions and seeing if they are different. So it is not as susceptible to changes in fraud pattern. However, I must say that it is not a substitute for traditional fraud model as at all, but rather we should look at these as complementary tools. We do all of this to fight fraud. Okay, next we'll talk about a proof of concept. This We used publicly available data set on credit card fraud to tune our unsupervised model and then tested it out on a holdout sample. There were about 28,000 good accounts and 492 frauds in in the holdout sample. And the results show that if we tolerate 14 for false positives, then we are able to capture 15% of frauds. If we tolerate 55 false positives out of we are then able to capture 30% of all frauds. And this model used only 20 plus fields provided, so there is potential to for superior performance. There is definitely a lot of opportunity for superior performance. So I hope you liked this discussion. If you have some questions, please follow up, and we hope to see you in future webinars. Thank you for joining this one.